evaluate from -2 to 2 sine of x over quantity 1 plus x quantity square rooted. 1 plus x squared square rooted. Okay, so this one creates all sorts of confusion. So your first thought is, all right, we have some 2 squares under a square root symbol. So inverse trigonometric substitution. And your thought process is, all right, so if we have 1 minus x squared where the sign is with the x, then you can do, well, x equals sine of u. But that's not what we have. You have an x squared minus 1 where the sign is with a constant. You say x equals secant of u. And if you have x squared plus 1, actually put some square root symbols here, then you say x equals tangent of u. But this really doesn't actually fit any of those because this looks most like tangent, but you're supposed to have the square root under it. And like, well, maybe we can square it, or I don't know. It becomes pretty tedious and difficult to solve. So that's not the way you go. Your next thought is, all right, we have this sign up here, so maybe we're doing a substitution. And that's not, there's no cosine there, so you really can't, it's very difficult to do a substitution there. You're like, well, maybe 1 plus x squared square rooted, you know, when you take the, it's like a equivalent for sine somehow, and it really isn't. So you can spend a lot of time spinning your wheels and not getting anywhere with this problem. So the key thing to see here, to keep a lookout for, which you wouldn't have an idea to look out for unless you'd seen this kind of thing before. Ooh, orange. So this value right here will always be positive. 1 will always be positive. X squared will be positive. You have negative x, but you square it, it then becomes positive x squared. And then by convention, usually the square root is a positive number. So the square root of 9 is 3, not negative 3. And even if it isn't, it's at least consistent. So this will always be positive. Or if you want to say the square root is negative, you can always say it's negative too. The idea is here is as x progresses from negative to positive, this denominator will stay the same. It will stay positive. Sine of x, though, will go from negative to positive. And that'll vary based on where x happens to be on the timeline. Specifically, from -2 to 2, that's probably goes from negative to positive. Probably something kind of like this. So the idea here is this is an odd function. It'll be symmetrical. Symmetrical? Mirror imaged. That's probably better. Mirror imaged along the x equals 0 or y-axis, if you will. So the idea here is if you have a sine curve, looks kind of like this, and you look at the area under the curve, and you add it from, let's call this -2 and this +2. If you add up this area here, they will cancel each other out because they'll be the same. They'll be mirror images of each other, but opposite. So when you have this is an odd function, meaning that it is a mirror image of itself. You could say, does it reflect over? I think it probably does. Either way, the definition of an odd function is f of x equals, or f of negative x equals negative f of x. And so the idea here is that the equation, the area under the curve on the right side will cancel out the area on the curve on the left side. You have -2 to 2 here, and so when you take this integral, it's all going to cancel out. And the answer here will be 0. So the other thought process you might have is, I panic, I don't know what to do. You could put this into your calculator. You put this in your calculator and you solve it from -2 to 2, and you should get an answer about 0. That'll take a while and it's prone to error. You can make a mistake and actually get like an answer, like, 1/2. And you're like, oh no, So it's usually better to not use your calculator if you can avoid using a calculator. So I'm going to quickly go to Wolfram. So we do, I know you won't have access to Wolfram on the AP exam, but this helps, I think this will help show the idea of where we're going here. So you have sine of x over square root of 1 plus x squared. Something like this. And if you look at this, it is, especially from negative 2 to 2, it is an odd function. The area under the curve here will cancel the area under the curve here. And so when you take the integral from negative 2 to 2, everything will cancel out. And that is the best way to approach this problem. It's really hard to kind of see that, though, because when you see this problem, you start getting all these ideas firing off, and you really kind of have to take a step back, look at this, and be like, okay, this is where this problem's going, and then just be like, 0. So, hope that helps. This is kind of a unique problem, and hopefully when you see a problem similar to this in the future, you'll be able to look at it and be like, okay, this is where this problem is, this is what I can do, solve. Hope that helps. See you on the next problem.